So here we are, question 55, trying to model the movement of a hawk, of all things. I used to dream of having a hawk when I was young. Anyway, let's see how you got on with this question. So what do you think I'm going to do first? I hope you're saying draw a diagram. So we're going to draw a diagram as a VT graph. So we've got T on this axis, V on this axis, and V is 0 when T is 0 and T is 4. So we've got our parabola going through these points, and because the coefficient of T squared is negative, it's going this way. So this is what a neater copy of the diagram would look like, just there. And we're trying to find the maximum speed of the hawk. So if this is T here and this is V here, then remember that the diagram is just a sketch at the moment. So where is my maximum speed? Speed is the modulus of velocity. So when velocity is negative, I can still have a positive speed. So the question is, which one of these points gives me the greatest speed? Now, if that's 4 there and this is 0, then this being a parabola, that must be t equals 2, and we know that we're only going up to t equals 8. So these are the two values of t that I need to look at, 2 and 8. So when t equals 2, v equals 8, and when t equals 8, v equals minus 32. So the maximum speed is 32, and it's important to put the units there as well. So we found the maximum speed. Let's see if we can find the total distance traveled by the hawk now. So the total distance traveled is going to be the area between the curve and the x-axis. But if we integrate, obviously we have to use integration to find the area. If we integrate from 0 to 8, then what's going to happen is that this area is going to come up as a negative. So we're going to not see the distance traveled then. So when we integrate from 0 to 4, we'll get a positive answer, but then we need to add on the integral from 4 to 8, but we need that to be a positive as well. So here we are, the total distance traveled is the integral from 0 to 4 plus the modulus, the absolute value of the integral from 4 to 8. And for this question, you could pop that into your calculator quite happily and get the total answer of 64, again, units, meters. Okay, so maximum speed, distance traveled, the furthest distance it reaches. How far is it traveling away from the starting point? Well, whilst it's traveling with a positive velocity, it will be going further and further away. So at this point, it's as far away in one direction as it can be, but then it starts coming back and traveling towards us. At some point, it's going to maybe go over our heads, and then when t equals 8, it will be as far as it can be in the opposite direction. So we need to know what the displacement is here and the displacement there. So we've got to find the displacement when t equals 4 and the displacement when t equals 8. So displacement is, as before, the integral from 0 to 4, that's 32 over 3. But when t equals 8, the displacement is minus 128 over 3, which means that the distance from the starting point is 128 over 3 meters. So then the maximum distance from the starting point will be 128 over 3, which is roughly 43 meters. So How did he get on with that question? There are other ways of solving that question, as there are with many of math questions. But hopefully you got the same answer that I did. If you did, well done.